You guys know the spiel by now. Huge shout out, huge thank you genuinely to all the sponsors that make this possible. This is an amazing conference so far. Make sure, if you haven't done already, go around, go to all the sponsor booths, get your stamps, and win a prize in the end. Board games, pretty cool. This talk is heavily inspired by the book of Stephen Hawking, who wrote On the Shoulders of Giants, going through all the scientists and scientific discoveries that he thought were fundamental to how we see physics today, how we see the world today. And I'm going to put a spiel on that and take it to the web development side of things. So this is my take on the people, but also the technologies that have shaped web development as we do it today. Obvious disclaimer, this is a hugely biased personal take on all of this. So this is my list of who shaped my experience with web development. Your list will very likely look different, and that's good. I highly encourage everyone to self-reflect on this afterwards and see, like, what is your biggest influence, what is your journey through web development. The whole point of this is to acknowledge that all of the technologies that came before kind of paved the path and gave us the abilities that we have today to actually build web apps the way we do. Cool. 45 minutes is not a lot of time, so I'm going to rush through some of this. I hope it's not too fast. But it's because we start at the very beginning, because there's no web development without the web. And this guy, Tim Berners-Lee, in the 1990s, he worked at CERN in Switzerland, and he was frustrated because he had to deal with a lot of scientific papers, and they were all in different formats and in different styles, and like it was a mess. So he really wanted a unified format, a unified language that all of these documents could be written in. He also wanted to be able to more easily cross-link them, like have hyperlinks from one document to another, or even within documents. So as one does, he went on and invented HTML. And that gave him pretty much what he wanted. So he had like a structured markdown language inspired by XML that allowed him to say, like, okay, let's use that as a common format, and let's use hyperlinks to link between documents. But he also needed to make a way to easily publish and then access those documents. And so he carried on, and he invented the World Wide Web. Not the internet. The internet came almost 10 years before. It was already there. He used the internet. This is one of my favorite pictures ever. It's Tim Berners-Lee on the left, and Vince Cerf, I hope I pronounced that correctly, one of the guys who invented the ARPANET, which became the internet, with very appropriate t-shirts wearing them. So Lee invented the World Wide Web, and he also invented the first web browser to consume those HTML documents, called Mosaic, which then became Netscape. But the internet at that stage, if we ignore gems like the marquee and the blink tag, which never made it to a standard, it was pretty static and it was pretty unstyled. So Hakonen Lee, also working at CERN, or sometimes spelled like this if you dig into old archives of the W3C, he led the working group on cascading style sheets. And in 1996, CSS became the official standard how you style things on the web. And the idea was that we were looking for something that's very closely integrated with HTML, but at the same time would separate the concerns of content and styling. And I want to at least touch on that because separation of concerns still seems to be like an extremely hot topic 30 years later. So the idea of separation of concerns was really, even in the very beginning, in the very first drafts of CSS, they were very concerned around how does the user actually consume this content. And the idea of being HTML, the content itself, should not be opinionated and should not be concerned with how it's consumed. That should be the user who decides how they consume it. But CSS would then allow you to style it specifically for whatever medium it is consumed through. So that could be a computer screen, but even in the first draft, they already thought about print, they already thought about audio only and all the other things. And that's the separation of concern. They were not concerned about, like, CSS has to be in a separate file or anything like that. That was another thing, just putting that out there. But yeah, so CSS introduced the style tag to HTML. It introduced the concept of classes to be able to target specific elements more easily. But that was pretty much it. CSS in the beginning was very basic. And as developers, we always want to have like more powerful tools. Like power is what we're after. So we invented CSS preprocessors. So mid and late 2000s, the most popular ones were probably Sass and less. And preprocessors gave us a lot of really good functionality. So they gave us things like variables, which is critical if you build design systems at any scale, really. They gave us cool things like nested selectors, so reducing the boilerplate that it takes to write CSS. They gave us mixins, they gave us functions, all of these nice things that help the developer experience writing or maintaining CSS. But importantly, they were built on top of CSS. So at build time, they would compile down to CSS itself. So they were really more focused on the developer experience. Browsers didn't need to care or know about any of these processes things. And then developers looked at that and were like, we have JavaScript. JavaScript has variables. JavaScript has functions and then some. Why not use JavaScript instead of reinventing something completely new? So CSS and JS became a thing. Does anyone here know what framework this code is taken from? Guesses? No. It's a trick question. This is actually code from a draft from 1995. It was before CSS actually became an official thing. It was an alternative proposal. When JavaScript came out, people looked at it with exactly the same motivation. We have JavaScript that has all of those things. Why don't we use all of the power of JavaScript in styling? And it was called JavaScript Style Sheets, so JSS, a lot of S's. And it did exactly that. So it extended the window document with a bunch of stuff that would allow us to apply styles in a JavaScript fashion. Imagine the world, how the world would look like if that actually took off. Instead, we have this. So this is an example of CSS in JS today. And it's much more built, again, on top of CSS, inspired by those CSS preprocessors. It's just pulling it into JavaScript. And the key thing here is the difference between JSS and CSS and JS is that CSS and JS is built on top. It's not a spec, and that's intentional. And all of these things, preprocessors and CSS and JS, because they're not the spec, they can move really fast, they can experiment with things, they can experiment with APIs, and they were the core of driving the spec eventually once we figured out what actually works and doesn't work. Another thing that we got in the CSS space is Houdini. Not this Houdini, this Houdini. Houdini was the idea of exposing low-level APIs to developers that gave us more control over the actual rendering engine. And I think the most famous thing that they gave as an example and that they hyped was to be able to do stuff like masonry layouts, which is really hard or impossible to do in CSS, but these APIs would allow us to actually hook into that and build those. And ironically, that's one of the things that is still kind of unfinished and kind of just trailed off. And I think it led to that false narrative of Houdini having failed, because that's what we heard the most, and then it just got silent, and now it's like in the void. But we actually got a lot of things out of Houdini, and that's worth acknowledging. It actually started in 2015. That's 10 years ago now. I feel old. We got CSS custom properties, which is just a fancy word of variables. That came out of Houdini. And even beyond Houdini, what I mentioned before of like preprocessors and CSS and JS inspiring the spec to be extended, we can see that trickling in more and more, especially over the last few years, with things like nested selectors. That's now in the CSS spec. Last year, I think, that shipped. We get more and more powerful selectors. We have the not selector, we have has, which is finally somewhat of a parent selector, which is pretty cool. We have scoped CSS. We have a lot of movement in the color space, which might not seem very exciting, but this closes the bridge between dev and design, which is really, really exciting, at least for me. And there's so many other things. HTML and CSS, we have view transitions, we have dialogues, pop-outs, more and more advanced abilities to actually style native elements. Like, we're getting closer to actually being able to style selects properly. This is exciting. And like people who say HTML and CSS are evolving too slowly and are moving too slowly, I don't think they're paying attention, because this is actually moving really fast for a spec. So really exciting times to keep an eye on. Let's talk more about JavaScript. and about this guy. Brendan Eich famously wrote JavaScript in 10 days. In 1995, he was hired by Netscape, and the idea was to create what he called the glue of the web. So we wanted to be able to add dynamic parts and dynamic behaviors to HTML. So we wanted a language that was specifically for that. The other goal was to make it simple. Netscape wanted non-devs to be able to write JavaScript and make their websites dynamic, which is somewhat ironic because JavaScript devs these days are famous for mocking HTML and CSS for not being a true programming language. JavaScript suffered from that for the longest time. So in 1995, the first draft was called Mocha, then he called it LiveScript, and then Netscape marketing jumped in and was like, Java is really popular, so let's just call it JavaScript and hope that that brings people along. And even though it was kind of like rushed out in 10 days, there were a lot of good things about JavaScript. JavaScript had functions as a first-class citizen, which wasn't, like now we take that for granted, but a lot of the languages at the time, like C++, Java, Pascal, they didn't have that. They were object-oriented and functions were more like an afterthought. We had no manual memory management, which some people might say like, okay, that actually is a foot gun, but at the time this was the whole point, is like make it easy for people, don't have to worry about it. Dealing with objects, dealing with arrays is super simple in JavaScript. Early JavaScript didn't have classes, that came later, but it had functional scopes, which is really powerful and lets you do very similar things. But if we look at the timeline, there's a glaring gap from 1995 in JavaScript to the mid-2000s when it actually started getting traction. So it really took a fair bit of time for JavaScript to become as popular as it is today. There's a bunch of reasons for that. The early browser wars made it really hard to consistently work on all the browsers. But one other reason was there was a different way to do dynamic stuff on the web, and that was called applets. And that allowed you to write stuff in Java or in Flash and embed that into your website and run that. And that was really popular because it just broke completely out, and you could do animations and games and all of that fancy stuff. And I hope I don't sound like an old person. Like, I do remember the web being full of Flash, and it was actually pretty cool. But then this guy came along. Or more specifically, the iPhone was released in 2007. And even ignoring like all of the security issues with Flash, so if we think about Flash, it's not just games and animations and stuff. We actually used it for website functionalities as well. If you wanted to put something into the clipboard of the user, you would use Flash because JavaScript wouldn't let you do that for security reasons. Flash didn't really care. You could do stuff like access to the file system, image uploads, downloads, whatever. So Flash was really useful to get around some restrictions. But it turns out, with the iPhone, suddenly people had browsers in their pocket. And it turns out Flash is really bad for memory, so it just drained the iPhone immediately. So Apple really quickly, really early made the call, we're never going to support Flash. And that kind of then killed applets as a thing. It gave way, or it gave a second chance for JavaScript to actually take off. And that coincided time-wise with another thing, which is driven by this guy, John Resig. He is the creator of jQuery. And at the time, he was working a lot on websites and web applications, and he was really frustrated because very common tasks were very tedious to do in JavaScript. And so he was inspired by libraries like Prototype, which extend kind of like the JavaScript prototypes with custom functionality. And he wanted to write something very similar for building web apps specifically. And the biggest pain points that he had were around finding elements in the DOM in your page. So he wrote wrappers that just gave developers a much nicer API to select elements using CSS selectors. Again, we take that for granted now because that's obviously the sensible way to do, but JavaScript didn't do that at the time. So this wrapper helped developers find elements on the page and then do stuff with those elements, adding classes, adding attributes, reading attributes, hiding, showing, dealing with animations, that kind of stuff. jQuery also had the benefit that it stood on the shoulders of other giants, famously Ajax. So in 2005, Google released Ajax. They weren't actually the one that came up with the idea. They just branded it and then released it. It actually came out of Microsoft, believe it or not. The Microsoft Outlook web team was tasked to find a way to make network requests from JavaScript to check if there's new emails available. And in good old-fashioned, the JavaScript API for this was pretty convoluted, but also like inconsistent between browsers again. So one of the big requests that jQuery had once it became more popular was add a wrapper for Ajax, and that's exactly what he did. And with Ajax and with the nicer DOM functionalities and the event systems, he basically had a collection of all the things that you really need to make building web applications much, much easier and much, much nicer. And today, jQuery has become somewhat of a joke and a meme. And I don't think we give it enough credit for what it's done, especially in the early 2000s, to get JavaScript where it is today. It was driving a lot of the ideas that we now have in modern JavaScript. And it was just fundamental to the adoption of JavaScript as a language. If we look at modern JavaScript, now we have like very nice query selectors. Again, all inspired by jQuery. We have much nicer event handlers and event systems. We got Fetch in 2015, finally, which is like the successor of Ajax, which again gives a much nicer API to do network requests from within JavaScript. So I'm kind of happy to die on that hill. That's one of the few hills I'm going to die on, is without jQuery, it's very likely that JavaScript just would have died in the early 2000s. Cool. Now that JavaScript is great, let's think bigger. What is the next step? Ryan Dahl, he is the creator of Node.js and also of Deno in 2018, which is the successor of Node.js, where he basically put all the learnings of 10 years building Node and built, in his own words, like a better version of it. And the idea of Node and Deno is, let's take the JavaScript engine that's in the browser, for Node it was V8, and let's just run it somewhere else. For Node, it was, let's run it on the server. So suddenly JavaScript became that full stack language that you can use on both sides. And that is cool in itself, but what I actually want to talk about is what that enabled us to do, or what that led to. Because at the time, it was 2010, there was no real standardized way to share and distribute code. So Isaac Schluter came up with NPM, the Node Package Manager. And again, it's become somewhat of a meme, the Node modules folder, famously the heaviest object in the universe, and yeah, there's some dependencies out there that seem a bit ridiculous. But overall, I think without NPM, the JavaScript ecosystem wouldn't be what it is. And I think most JavaScript developers, definitely me included, appreciate the vast community-driven packages that we have available to our fingertips to just build stuff very quickly. And I want to specifically highlight two categories of stuff that we got out of NPM very early on and that shaped the way we build web applications. One is build systems. So stuff like Grunt, Gulp, Webpack, it basically allowed us to build more sophisticated build setups for more sophisticated apps, really. So we talked about preprocessors. If you want to have a CSS preprocessor, cool, just add a build step for that. If you want to build for production, you probably want to stitch files together and then minify them so they run more efficiently in the browser. Cool, add a build step for that. And most importantly, if you want to write modern JavaScript but still serve to all the browsers, add Babel and add a build step for that. Babel really allowed us, again, as a JavaScript community, to take advantage of all those packages building on top of the specs and use them and iterate over them to find the best APIs from a developer experience to then feed back into the specs and evolve the JavaScript spec as it is. So I would keep repeating myself on this point. Somebody told me, if you want to make sure people understand the point that you're making, you have to repeat it at least 7 times. I think we're at 4 or 5 at this stage, so a few more to come. But the build systems itself, they also evolved. So we have the rough Gulp, Grunt style in the beginning, and then Webpack took over, and Webpack became really, really powerful. You could do a lot of things on Webpack. but it also arguably became very complex. It's probably the biggest criticism of build tooling itself, is like it just adds so much complexity, you can't just quickly jump in and do something. With Vite in the last few years, I think we finally reached a sweet spot where we have a lot of power, but also we're back to simplicity in certain extents. The second category of things that we got is utilities, which again, some of those might seem like ridiculous, but there's really good reasons why we keep identifying stuff that's wrong with the spec and then building on top of that and trying to fix them to then inform the spec how it can actually do it better. Lodash, or underscore, how it was called in the beginning, is a really good example. I hope some of you in the room still remember the days when we had to do all of this, when we went for a deeply nested object. So like to set foobar hello world to this is crazy, we had to check that everything on the way isn't undefined because JavaScript would just throw. Lodash identified that and gave us a function that just helped make this a lot neater and a lot nicer. In a very similar way, and probably more controversial, leftpad is also a really good example. If we ignore, it definitely became a meme as well, if we ignore the whole unpublish the package kind of disaster that happened, what leftpad did was it saw that, okay, padding a string to the left or right, doesn't matter, to a certain length is unnecessarily convoluted in JavaScript itself. So he wrote a little helper that did that, and then published it to NPM, and it became really popular. I'm not saying you should use third-party NPM libraries for every little thing that you do. I'm just, again, trying to point out all of these libraries actually eventually led to the spec being fixed because we identified, okay, they're actually just trying to work around issues that we have in the core spec. So we have, in modern JavaScript, we have optional chaining now, which solves the whole deeply nested arrays or object problem. And for leftpad, we have pad start and pad end in the JavaScript spec now on the string prototypes. So again, the spec looks at the open source system and tries to learn from all of those. Cool. This kind of starts the final phase of the giants that I want to talk about. This is very much a personal one for me because this was the first framework that I worked with. Yours might be very different from that. So Steve Sanderson, he's the creator of Knockout.js. And Knockout.js, I would call it like one of the first JavaScript app frameworks. We might disagree on the definition of what a framework versus a library is. What I mean with framework is that it tried to collect everything that you need to build a web application. And web applications in themselves, they're basically just a bunch of state that you want to be able to manage, and then that state gets represented in the DOM, aka in the UI. That's really all web apps are. So you might have used a different library, you might have used Backbone, you might have used Angular. Knockout basically tried to do all of that by introducing two things. They introduced the concept of observables. So you assign a variable a value, but it also can then easily keep track of that value changing, which helps you with that whole state management part. And then with the translation into the DOM and translation into the UI, they added the templating layer. So this was actually one of the first libraries that tried to move that templating layer away from the backend into the front end, and we became like a full JavaScript framework. If you look at, like, it was then quickly followed by other libraries or frameworks. Angular I already mentioned, React, which became really popular, Vue. And if we look at all of these, they all kind of follow the same ideas and follow the same designs. This is early Vue, so this is like version 1 or 2 if you play with Vue, and it looks very similar to Knockout. So you have your templating at the top, and again, the state management, the scripting at the bottom. If we look at React, React revolutionized a little bit like where we put the templating. It pulled it into the JavaScript via JSX. But at the end of the day, even in this modern form, even with like hooks and stuff, it's still very similar and it's still familiar, trying to do exactly the same thing. So all of this kind of started the era that we're still in with single page applications. So the idea is we can actually build our whole app in JavaScript, so we can run everything on the client. And I think we very quickly, at least for some use cases, realized that we went a little bit too far. And the next phase, we basically tried to take advantage of Node.js being able to run on the server, so we can run JavaScript both on the server and the client, so let's just go back to server-side rendering. Gatsby was the one that kind of pioneered that, and then Next.js and Remix made it more and more popular. And the idea basically is that you build your app in one code base, but then you run that JavaScript on the server once to get the static HTML, so that your initial response from the server can already have content in it. And then you also ship that JavaScript, so on the client, that JavaScript can take over and you get all the benefits from the dynamic single-page application feel that we know and love. And this is example code from Next.js, but they all, again, they look very similar. They do very similar things. So you still define your components, but you can also define other functions that then do stuff on the server, like fetching data from the database or stuff like that. So the idea was we were trying to get the best of both worlds. Let's keep our JavaScript frameworks, but let's also render them on the server. Before I actually move on to where we're at now and what might be coming next, I want to give like an honorable mention that goes beyond the web, because I'm mostly focused on web development here, but JavaScript is everywhere now. And I think one of the early reasons for that is a library or framework called PhoneGap. I don't know if people remember PhoneGap. It's basically the jQuery of mobile development. So the idea was, let's build native mobile apps, but with JavaScript. And PhoneGap did it in a very sneaky way. It's just basically a glorified web view. So it wraps a web view, and then you can just render with your HTML and JavaScript as you would in the browser, but it's running as a native app. And it sounds too simple to be a good thing, but at the same time, that pushed the boundary. It was thinking outside of the box. And by being a wrapper and having that web view, it was able to inject extra functionality into that web view that allowed you to build what felt like a native app. It allowed to inject like custom events, so you could listen for mobile-specific events in your application. It was able, through the plugin system, to inject certain functionality that we didn't have in JavaScript. So you could get access to the camera or advanced network information or the file system of the device, or even like the device itself, like triggering vibrations and stuff like that. Again, very similar to jQuery, PhoneGap, or Cordova, what it's called now, became a little bit of a meme because it was so simple and just a web view and all of that. But I think it really pushed the boundaries and really helped us understand, A, what we're missing from the current JavaScript spec. So all of these APIs are now core web APIs in JavaScript. We can do that in the browser, on the phone, whatever. We have the media capture API for camera. We have network information API, which is literally a carbon copy of the Cordova plugin. A new file system API, which is pretty powerful. Vibration API has been around for a while. So the web API is really caught up in that sense. But it also, again, shaped the way for other libraries taking over and evolving the idea into something more mature. I'm mentioning Electron here. Electron is basically still doing the same thing, but getting away with it. Basically just bundling Chromium. But it's a cool way for JavaScript developers to be able to build native desktop apps, which is cool. React Native on the mobile side definitely evolved the whole concept. React in itself, basically making the concept mainstream that React, the core library, is completely independent from where you want to render it. And then you have different renderers for the different platforms. So React DOM for the web, React Native for mobile and smartwatches and smart TVs. But even other things, like the sky is the limit. There's React renderers for the terminal. Ink is a really good library that allows you to build dynamic CLI tools very easily. There's renderers for AR and VR. There's a renderer for 3D printing. Like, it's really cool, and it's really like just pushing what's possible. All right. Where are we now and what's next? So this is basically just a collection of current hot topics that I personally think are worth keeping an eye on and worth following along. Again, same disclaimer as in the very beginning. This is my opinionated list. You might have other things that you're really excited about. I'm not going to talk about Web3, crypto, or any of that. Sorry about that. But I think there's a few topics in here that are worth just putting attention to. The first one is partial and zero hydration. So basically going back to that server-side rendering bit, one of the big problems with classical server-side rendering is the hydration piece. And to understand what the problem is, we have to kind of look at how the browser renders server-side rendered websites at the moment. So if a user goes to a website that says we built in Next or Remix, the browser makes a request to the server runs all of your JavaScript to create that initial HTML like I described. It can't do much more than that because on the server you don't have a concept of dynamic stuff, like there's no state, there's no event listeners or anything like that. So we create that initial HTML and then we send it back to the client, but we have to send all of the JavaScript with it. And then the browser has to run all of that JavaScript again to essentially create a virtual copy of your whole application just to be able to inject the dynamic parts, again, state, event listeners, context, you name it. That's what we call hydration, and I hope it's somewhat clear like how inefficient that is. So in this example, all we're really doing is injecting the event listeners into the buttons for the carousel. The rest of the page doesn't change, but we still have to execute all of that JavaScript just to find those dynamic elements. So the idea with things like React Server Components or other frameworks like Astro and Quick is that we want to find a way to tell the bundler which of our components are static and only ever need to be rendered once on the server, and which of our components are actually dynamic and need access to dynamic stuff, like client-side stuff, but also need to be shipped to the client and need to be hydrated. So React Server Components do that in, I think, a very smart way. So by default, everything in React Server Components is treated as static. So again, you don't have access to state and all that fancy stuff, but you can make your components asynchronous functions. Because again, we know it's only going to run once on the server, so we can actually do server stuff in our component render. So we can go to the database and fetch the user data or whatever. So that's really neat, but if we do need access to event listeners, context, state, we just add the use client directive at the top of the file, and that tells the bundler explicitly, okay, this is a client component, this needs to be shipped to the client and needs to run the hydration piece. This is why this whole process is called partial hydration, because we can be very specific about what needs to be hydrated and what needs to be shipped to the client. So realistically, in a normal app, this can massively reduce the bundle size, the JavaScript bundle size that we're actually shipping over the network. Astro, as a framework, as an alternative, tries to do exactly the same thing. It just approaches it very different from a developer experience perspective. So Astro just makes it very clear through the file structure which parts of the code actually run where. So the top part of the file is what's going to get run on the server. So that's where we do like the database requests and stuff like that. The middle part is the templating, also only run on the server, but it gets access to the top part where we have variables and stuff like that. And then the bottom bit is where the JavaScript lives, and that's the only thing that gets shipped to the client, and it gets actually run on the client as like the hydration piece. And this is great because it removes a lot of that magic that people might feel is happening in React. It does also mean it's more tedious to actually do full-on dynamic stuff, so it's a trade-off, but worth playing around with. The other library looks Quick. Looks a lot more like React again, but it goes, or it tries to go a lot further. So Quick goes very aggressive with the code splitting. So if we look at the component here, every closure, so for example, the on-click callback, gets bundled in its own little chunk. And if we do that, we have much more control over when we actually load those chunks. So we don't need to hydrate when the page is loading. We can be more specific than that. So for the button, we can say when the user hovers over the button, that's when we load the chunk. Or even more aggressive, when the user clicks the button, that's when we load the chunk. The other thing that Quick is doing is it actually tries to get state, the concept of state, into the server. So the server actually runs your application with state and then persists the state in the DOM as like custom data attributes in a serialized way. This way, the client doesn't have to hydrate, it can just continue where the server left off. So if we have the counter here, when I click the button, it will grab the current count from the data attribute rather than having to be hydrated before. Anyway, long story short, the whole point is that Quick tries to go to zero hydration in the sense of it doesn't need to load on initial page load. It can be more explicit about when the user interacts with a thing, that's when we load stuff. The next thing that I think is really exciting, and I'm personally very excited about, is out-of-order streaming. So there's another problem with traditional server-side rendering, especially if we look at the examples that I just had for the other slides. It's the server response time. So if your server actually does a lot of stuff as part of the rendering, the server response time can get really slow really quickly, which leads to a very bad user experience. Suspense, React Suspense on the server tries to address that, and it finally shipped in stable in React 19, I believe, last year. And how it does it is, it basically, if we look at traditional server-side rendering, this is what I described before. If the browser makes a request and we do a bunch of stuff to generate the HTML, the browser has to wait till everything is finished until we send it the HTML, and then we render the whole page. So this can take quite a long time. If we introduce classical streaming, we can at least allow the server to start sending stuff when it's ready. But classical streaming is limited because it has to be sequential. You have to send the HTML in the order that you want it to be in the final document. So if your second element on the page is actually the one that takes so long, the user still just sees a header and it's still a bad user experience. What out-of-order streaming tries to do is to allow us to stream out of order. So it's very well named. Basically, the idea is that with a little bit of JavaScript, we can allow the server to send an immediate response that just includes placeholders for everything that's not immediately ready. So anything where you need to fetch data from the database or whatever, it will just put a placeholder in for now, and then we allow the server to keep streaming when stuff gets ready, and we just swap out the real content or the placeholders with the real content once we have the real content. So it doesn't introduce new technology, it just uses streaming as we already have it with a little bit of JavaScript to allow us to build a much more dynamic and much better user experience. And this is why I'm excited about it, is because it's not necessarily tied to React or any front-end framework in any sense. Yeah, React does a lot of other things as part of it to just make it work better with React, but you really just need 4 or 5 lines of vanilla JavaScript so you can easily apply the same concept to other languages like PHP, like .NET, like Elixir. So for me, it's really excited to just see where does this go in the next couple of years. All right. This one is an interesting one. So people started calling it the carcinization of frameworks. And carcinization, I love this word. It's basically describing in biology how, in simpler words, how everything just individually, nature just keeps evolving things into crabs. So crab being like the superior form of animal, apparently. This is very simplified and not actually true. But the idea is that individually things evolve into the same end thing. And in JavaScript, we have that in a couple of places. I want to point out 2. One is driven by this guy who really should have been in the list of giants. It's Evan You. He's the creator of Vue.js. And more recently, he created Vite, which I touched on very briefly. So Vite is one of those build tools that we now have. And Vite feels, like I mentioned before, we had a lot of build tools in the past as well, but Vite feels very special. For one, like I said, it starts hitting that sweet spot between power and simplicity. So it's extremely powerful, but also it's easy to use. But also it managed to pull a lot of stuff that frameworks had to do or in the past used to do themselves. So stuff like hot reloading and other things. Vite now takes care of that, and frameworks more and more just let it do the heavy lifting to the point where they eventually just start sharing the toolkit and focus on what the framework actually is supposed to do a lot more. And the best example for that is Remix, which last year or early this year did the whole rebranding thing again. So Remix became React Router again, and the new version of React Router is really just a Vite plugin. But without losing any of the functionality, you can still do all the server-side render stuff, you can still do everything that you were able to do with Remix, but now it's just a plugin of Vite. And it just shows how powerful that underlying toolkit is, and more other frameworks will just start using the same toolkit. The other thing that has a very similar story where all of the frameworks seem to be evolving into the same direction is signals. Not these signals, these kind of signals. This would be a much harder Google capture if you had to do that. The idea of signals is basically what I tried to explain before with Knockout.js, that it introduced the concept of you assign values to a variable, but then you're also able to keep track of the value of that variable whenever it changes. You want to have some side effects like updating your DOM, etc. Signals are a very efficient way to do it. Like I said, Knockout called it observables. Vue calls it refs. Svelte calls it runes, I think. Solid.js, I believe, was the first one coining the term signals. I might actually be wrong on that, but they definitely made it mainstream. And React is ironically the only major framework that doesn't use signals. So they didn't jump on the bandwagon, but everyone else kind of evolved independently into the same solution for the same problem. And based on all that, the clear next step is, okay, let's make it a standard. So there's a TC39 proposal for signals, and it basically tries to do exactly that. So make signals a first-class citizen in JavaScript. So we have a core implementation that just works for everyone. Frameworks can still build on top of that if they need to, but the idea is that this one core implementation then can optimize for all of the different use cases. And more importantly, once we have a standard, once we have a spec, browsers can start optimizing for it as well. So that might be a really exciting time when we see that happening. Performance and a lot of other things might just spike because browsers can actually start optimizing for the specific implementation. Finally, the last one that I want to mention is WebAssembly. And this is a little bit of an odd one because WebAssembly has been around for a while. WASM, more specifically, like WebAssembly focused on the browser, came out, the first version, in like 2017. And the idea of WebAssembly is you can write code in any language you want. So be it Ruby, be it Go, be it Python, be it whatever. And it compiles down to something that it can then run in the browser. So it basically comes with a bunch of tooling and then allows you through JavaScript to just basically run that native code that you've written that might run much, much closer to the machine code, and therefore like the promise is better performance and all of that stuff. You run that in an isolated environment. So this comes very close to what we had with applets. It's just a much better architecture, much more secure, and much wider as a concept. Now, again, this is exciting in itself because it starts finally getting traction now. But the more exciting thing is actually WASI. So WebAssembly system interface, which takes that whole idea and does what they actually originally planned to do, is like, okay, write any language and run it anywhere. Not just the browser, just like on the server, like Internet of Things, like whatever you can think of. Write in the language you want, compile it to WASI, and run it anywhere. So I think that's really exciting to keep an eye on. And the other thing to keep an eye on is Houdini, because maybe one day it's actually finally ready yet. We'll see. This is all I have time for. This is a QR code with the slides. Some socials, I'm not very active on socials, but everyone shares them on their slides, so there you go. And once again, a huge shout out to the sponsors and huge thank you to all of you guys for being here and listening to me. Thanks.